Welcome students. How you guys doing today? I hope y'all are good, y'all are fine, y'all are well, and y'all are doing things. So today we are going to be talking about a very nice topic in physics called linear motion. This topic is so awesome and I'm gonna explain it so well. So stay tuned and let us get into this video. Oh, before we get into it, please hit that like, hit that share, and hit that comment and tell me what you think about the video and tell me what other videos you'd like to see me do. Okay, and I'm also a first year student at the University of Western Cape. So without further ado, let us get into today's video. A whole entire mood. So the vlogation. Radio set. So as I said, we are talking about linear motion. Motion is relative. Motion is between two objects. So now me, you, my camera that I'm using to record this video, and everything else in the universe is moving at a speed that is relative to the sun, and the speed is about 30 kilometers per second. That is pretty fast. Very fast. And that speed is even greater to stars that are much more further than the sun. So now if there's a car and me and we are moving to each other, our motion is relative to each other. So everything in the universe is relative in motion to the other object. So now these two pens, if this pen is standing still and this pen is moving, their motion is relative to each other. That is what motion is relative means. So now we are gonna get into speed. So speed is equal to distance over time. So speed is the distance traveled over units of time. The distance traveled over the units of time. So now for you to calculate your speed, you're going to say your distance, your total distance covered divided by the time. And then you also have instantaneous speed, which we have as instantaneous speed is speed at an instant. It comes from the word instant. So instantaneous speed is if a car is moving and then you check the speedometer and you find that at that moment it is 60 kilometers per hour. It means that the car is traveling at 60 kilometers per hour at that instant, and that becomes your instantaneous speed. Usually when a car is moving, the speeds are not the same, because now the car, it's most of the time impossible for the car to move at the same speed over a long period of time. So your speed varies and it variates, and then when you check your speedometer and the speed that you find at that moment become your instantaneous speed. So now because the speed of a car varies, we become more interested in average speed. Average speed is the total distance traveled over the total time. So now the average speed include all the variations of the speeds that we traveled, that all the variations of the speed that were experienced by the car during the time of travel. So now speed is distance over time. Instantaneous speed is speed at an instant. And in a car, to find instantaneous speed, you just look at your speedometer, and then your average speed is different from instantaneous speed, because average speed is the average of the total speed divided by the whole time of travel. So that is where we are with speed. And then to get your total distance covered, you're going to say speed multiplied by time. Whatever your speed will be, you multiplied by your time. And usually we multiply the speed by the average speed, and then the time is the whole time of interval. With that said, now we are gonna venture into velocity. So velocity and speed have the same unit of measurement, which is meters per second, or kilometers per hour. So it puts together your distance and your time. And then now velocity is your speed, but then when your speed has direction. So now velocity is speed with direction. Your velocity is speed with direction. We can have constant velocity and changing velocity, right? So then for your velocity to be constant, it means that you are moving in a straight line and you are not gaining speed or losing speed. If your car is moving at 60 kilometers per hour, it must move at that speed for a period of time for your velocity to be considered constant, right? The moment your speed changes, your velocity is no longer constant. Once your direction or you move to a curve, then your velocity cannot be constant. For you to have constant velocity, your speed must be the same and your direction must be in a straight line. Once there's a change in this or this, you get your changing velocity. And in most cases, your velocity is changing. It is in very, very, very rare cases that when you are driving, you travel over constant velocity over a long period of time. Which then brings in another important aspect, which is called acceleration. Acceleration. I'm sure my spelling is wrong. Acceleration. Is it? Sure, yeah. But then acceleration has to do with velocity and time. So your acceleration is the change in velocity over the time of travel. The change in velocity over the time of travel. So if the speed is constant, it means that your change in velocity is 0. Because if your speed is constant, the initial speed will be 60 kilometers per hour and your final speed will be 60 kilometers per hour, and then your initial minus your final minus initial will become 0, and then there is no acceleration because it is 0. But the moment your velocity changes, then you get acceleration, right? The moment your direction, when you're traveling, the moment you change your direction, it means that you are changing your velocity. Or the moment you change your speed, it means that you change your velocity, and that is when acceleration comes in. So when velocity changes, then we get the acceleration. Acceleration can be positive, and acceleration can be negative. The condition of positive for acceleration is when your car gains speed. When you are traveling initially at 0 kilometers per hour, and then at the final you're traveling at 100 kilometers per hour, there is a change and an increase in velocity, which means that there is an increase in acceleration. But if you are traveling at 100 kilometers per hour, then at the final you have 10 kilometers per hour. Now there is a change in velocity, and your change in velocity is decreasing velocity, which means that your acceleration in time will also be decreasing acceleration, and that is a special case called deceleration. Okay, so when you're traveling in a car and you apply those brakes, then your car slows down, then you are deaccelerating. You are no longer increasing in velocity, and you are no longer increasing in speed, and you are no longer increasing in acceleration. So that is how you distinguish between acceleration and deceleration, and never confuse acceleration with velocity. And the unit of change of acceleration is per meters squared, because now you are the first S comes from the S from velocity. Then the second S for time comes from the time which you are dividing by. Okay? So now you mustn't confuse acceleration and velocity. Remember, velocity has to do with speed and direction, and then acceleration has to do with the change in velocity. So if there is no change, then we are talking about the velocity. But when we put the concept of change of velocity, just know that we are talking about acceleration. And then acceleration is the rate of change of velocity over a period of time. Right. With that said, now we just described linear motion that was occurring horizontally, right? And then we have our y. Now, what happens when it is occurring vertically? Now, when it is occurring vertically, we have a whole new thing. And then remember that a projectile, when it is falling under the influence of gravity, it is in free fall. So when only gravity is the only thing that is affecting this object that is falling down, the object is in free fall, right? Free fall. Okay, so now objects that are in free fall have to do with how far and how fast. So now how far has to do with distance, né? And then how fast it has to do with velocity. So now we're gonna start with how fast and explain how fast and how fast works. So then now when an object is falling, guess what happens? It gains velocity because it is being pulled down by the gravity, right? It is accelerating down, and the force that is pulling it down is the force of gravity from the planet Earth. So now when an object is falling down, it gains speed. So then now let us say you have a projectile from rest and then you drop it down. Okay? When your object falls, it's gonna fall 1 second, 2 seconds, 3 seconds, 4 seconds. Let's say it falls for 5 seconds. Then it falls for 5 seconds. Then you have the 0 second. So now as it goes down, like I said, it gains velocity, it gains speed. And then when it gains speed, initially, since at 0 second is where you drop it, your velocity will be 0 meters per second, right? And then after 1 second, it gains a speed of 10 meters per second for each fall of interval, right? Gains 10 meters per second. So after 1 second, it is going to have 10 meters per second. And then the velocity after 2 seconds, it will gain 10 more meters per second. So it's going to be 20 meters per second. And then after 3 seconds, it becomes 30 meters per second. After 4 seconds, it becomes 40. After 5 seconds, it becomes 15. So what this tells us is that a free-falling object gains a speed of 10 meters per second per each second of fall, right? Excuse me. So now this introduces the thing of acceleration. Now we want to find acceleration. Remember that acceleration is the rate. So acceleration is change in v over time. So now we want to find the acceleration of these things. And one thing we should know, the acceleration of free-falling objects is constant. And then now we can say that this acceleration is also equals to gravity. Why? Why do we say it is equals to g? Because the only thing that is pulling it down is acceleration due to the force of gravity only. And then g is 10 meters per second, right? Well, the precise number is 9.8, but in this case we're going to use 10 meters per second so that we can understand the concept properly. So now we need to prove that for each and every second of interval our acceleration is 10 meters per second. Remember that acceleration is the rate of change of time. So now we're going to use the first second. So now we're going to find our gravity by saying change in velocity during the first second of interval, which is our change in velocity is Vf minus Vi over T2 minus T1, right? For the first second, our Vf is 10, and then our Vi is 0, and then our T2 is 1, and then our Ti is 0, because we are using these two. And then now we find out that 10 minus 0 is 10, and then 1 minus 0 is 1. And this will give us 10 meters per second squared, right? And then for the first second, we're going to do the same thing. We're going to have 20 minus 10, because our Vf now becomes 20 meters per second for the second. Then our Vi becomes 1 meters per second, 10 meters per second, and then our T2 becomes 2 seconds, and then our T1 becomes 1 second, and we also get 10 meters per second. And then even if so as you can see that so now even if you use the third second, the fourth second, or the fifth second, you will get the same answer of constant 10 meters per second, which is when we get our answer of gravity due to acceleration being this. So always know that your gravity due to acceleration will give us this answer. Okay, so now that we know how fast, we know that a projectile gains a speed or a velocity of 10 meters per second of fall, and then our acceleration due to gravity is always 10 meters per second, right? Now we're gonna go to how far is interested with distance, and then how far is equals to d is equals to half gt squared. This is our sum. So now we are looking for the distance. So now we're gonna have 0 second, 1 second, 2 second, 3 second, 4 second, and so on. So now obviously in the 0 second our distance will be 0, right? Because now remember, we're gonna take our calculator and say half. We're gonna say half, and then remember our g is 10 meters per second, and then we say 0, and then for our t we have 0 squared, and then we're gonna have our answer of 0. Then we're gonna have our answer of 0 meters. And then now for 1 second you take the t, and then you put your 1, and then you find your answer. You find your answer of 5 meters. For 2 seconds, you just go to your sum, you put a 2 there, then you find your answer of 20 meters. Then for 3, you do the same thing. You put your 10 for g, and then for your time, you put your 3 there, and then you get 45 meters. And then for 4 seconds, you put your 4 there for t, and then you get 80 meters. And then you get your 80 meters. So this tells us how much your how far changes for each and every second, how your distance changes for each and every second. And then whenever you are calculating your how fast, you just know that you need to use a v, change in v over t. And then now, but in most cases, now for this acceleration, we use average average velocity, which is average velocity is VF minus VI divided by 2. So now, as you can see that if you want the average velocity of the first second, you're gonna say 10 minus 0 divided by 2, which will give you 5. And then if you want the average velocity, the average velocity of the first 2 seconds, you're gonna have your 20 minus 0 divided by 2. 20 minus 0. Okay, that is obviously gonna give you 10. Then for the 3 seconds, you're gonna have 30 minus 0 divided by 2, and that is how you calculate your average velocity. In projectile motion, we are more interested in average velocity than this one. Okay, and that covers our topic of projectile motion. Then before I end this video, we must always remember that when an object is going up, when an object is going down, the initial velocity is 0, and then as it goes down, it gains velocity because it is going down to the force of gravity, which pulls it down and it gains speed. And then if I'm drawing the object up, it has an initial velocity because it requires force to be drawn up, and then as it goes up, it loses speed because it is going against the force of gravity, and while going up, it loses speed at the rate of 10 meters per second. So now if it's going to have a 3-second interval and I give it an initial velocity of 30 meters per second, and initially it's going to have 30 meters per second, after 1 second it's going to be 20 meters per second, then after 2 seconds it's going to be 10 meters per second, and then after 3 seconds it's going to be 0 meters per second, which is where it is going to stop. And then if I'm projecting the object upward and then it comes down, projecting it up and then it comes down, initially it's going to require a velocity, and then as it goes up, it's going to lose velocity at the rate of 10 meters per second. Then when it reaches its top point, the velocity is going to be 0. Then while it goes back down, it's going to gain velocity because now it is going down with the force of gravity, which is pulling it down. Then it's going to gain the velocity in the same proportion as while it's going up, but in the opposite direction. So now if my initial velocity is 20 meters per second and I'm drawing it up, after 1 second my velocity is going to be 10 meters per second, and after 2 seconds it's going to be 0 meters per second, which is the top of the point, and then at that point it's going to go down. Then after 3 seconds it's going to have a velocity of 3 meters per second, and after 4 seconds it's going to have a velocity of 4 meters per second. So now let me give you an example. So now if I project an object like that, and my initial velocity is 20 meters per second at 0, after 1 second it is going to be 10 meters per second, after 2 seconds it is going to be 0, the velocity, and then after 3 seconds it is going to be back again 10 meters per second, but in the opposite direction, and then after 4 seconds it is going to be 20 meters per second, right, while it is going up and down. But then if it was just going up, we would only have this one only, and then if it was going down, we would only have this one only. So when an object is projected upward, it needs an initial velocity, but when it is projected downward, it doesn't really need an initial velocity. And then that covers our topic of linear motion. Thank you very much for watching this video. I hope you enjoyed it. I hope you grasped some topics, and I really appreciate it. It really means the world to me. I cannot wait to see you again in the next tutorial video that we're going to be doing, and please let me know of other videos that you would like me to cover. And thank you for watching. It means the world to me. All the world. Science, power to science. I will see you in the next video. Thank you.